Torque is an important concept in machines with a cylindrical air gap, a fundamental principle in the world of physics and engineering. Torque, in its simplest definition, refers to the rotational force that is generated when a magnetic field interacts with a current-carrying conductor. It's a concept that may seem somewhat complicated in the beginning, but its understanding is indispensable for engineers and physicists alike. To gain a clearer understanding, let's break this down into simpler terms. You can think of torque as a kind of force that causes an object to rotate around an axis. Now, you might be wondering, how does this force come into being? What generates it? The answer lies in the unique interplay between electricity and magnetism, a fascinating dance of nature that forms the basis of many of the machines we use on a daily basis. In machines that incorporate a cylindrical air gap, this force, or torque, is generated by the intriguing interaction between the magnetic field produced by a component of the machine known as the stator and the current that flows through another component called the rotor. The stator, as the name implies, is the part of the machine. It's like the fixed anchor around which the rest of the machine operates. The stator is responsible for producing a magnetic field, a field of magnetic energy that is created by the flow of electrical current through the stator's windings. These windings are typically made of copper or other conductive materials, and their shape and arrangement contribute to the strength and orientation of the magnetic field. Now, let's talk about the rotor. Unlike the stator, the rotor isn't stationary. Quite the contrary. The rotor is the part that is meant to rotate, hence the name. The rotor contains a current-carrying conductor. When this conductor comes into the magnetic field produced by the stator, a marvelous thing happens. The magnetic field interacts with the current flowing through the conductor, and this interaction creates a force. This force, my friends, is what instigates the rotation of the rotor. The strength or magnitude of the torque produced in this process depends on several factors. These include the strength of the magnetic field produced by the stator, the amount of electrical current flowing through the conductor within the rotor, and the length of the conductor that is situated in the air gap. By manipulating these factors, engineers can precisely control the torque output of the machine. This capability of controlling the torque is of paramount importance in various applications. It finds use in electric motors, where the torque dictates the power and speed of the motor. It is also vital in generators and other rotating machinery, where the torque can influence the efficiency and reliability of the machine. In these machines, the ability to control the torque allows for optimal performance, energy efficiency, and even the longevity of the machine. Therefore, understanding and managing torque is not just about knowing a physical concept. It's about harnessing the power of physics to create machines that are more efficient, more powerful, and more reliable. In conclusion, torque is the rotational force generated in machines with a cylindrical air gap. It is a fundamental force, crucial for the proper functioning of these machines. By adjusting the magnetic field, current, and conductor length, engineers can control this torque, thereby tailoring the machine's performance to the desired specifications. This underscores the importance of understanding and controlling torque, a vital principle in the realm of machinery and engineering.